But now we are ready for experiment number 4. Rather than blocking one of the beams in the modified SGX device, I'm going to not block either of the beams. So the N0 atoms that have Sz equals plus h bar over 2 will be split according to their Sx values and then recombined. N0 atoms will come out, and now I'm going to measure the Z component of spin, and what would happen is the same as what would happen if there was no modified SGX device there at all. The modified SGX device has sort of made a measurement, but then it put things back together again so that no outcome of the measurement can possibly be known. And you would get 100% Sc equals plus h bar over 2. All N0 of them would come out the upper output. So this modified SGX device does not create 50% plus x and 50% minus x states. But what's really astonishing about this situation is if we compare these two setups, notice what's happening. In the upper setup, I have a beam blocked, and if I remove this barrier, I obtain the lower setup. When I remove a barrier, fewer particles, namely no particles, come out of the SGZ device lower output. By unblocking a path, I have reduced the number of particles coming out of this output. That's really weird, and we're going to have to do a little bit of work to figure out how we're going to describe these phenomena if you can add together beams and make things go away. For the record, let me write that down. The implications of that are we need to discuss things not in terms of probabilities of particles coming out of one output or another, but something more sophisticated. We need to consider probability amplitudes, which can be positive or negative and can interfere with each other.